Hello, this is the first video of a 4th vector series for OCR Pure Core Further Mathematics, and the title is The Equation of a Plane in Parametric Form. We have already seen that there is more than one way of writing the equation of a line in 3D, and the same is true of the equation of a plane. So this video will look at writing the equation of a plane in parametric form. This is a convenient form when you know either two direction vectors that lie in the plane along with a point in the plane, or when you know 3 points in the plane. So if we know the position vector of a point on the plane, say A, then we can get onto the plane, if you like jump there from the origin using A. We can then use multiples of non-parallel vectors B and C to get to any point on the plane. So R will equal A, the position vector of a point in the plane, as shown here, plus lambda, which is a scalar multiple of direction vector B, plus mu, another scalar multiple of direction vector C, remembering that B and C must not be parallel. So if you already know two direction vectors in the plane, you can just use these as B and C. You may remember that a vector equation of a line had only one parameter, lambda, and so this is a very similar idea. Here you can see that we have jumped from the origin onto the plane using A, and then once we're on the plane, we can move around using these vectors that lie in the plane. In this example, we're asked to find a vector equation of a plane containing the 3 points P, Q and T as given. We know we want to use this form of the equation. We're going to use P as our jump-on point, or A, and then we want these direction vectors B and C. Let's choose PQ to be our B vector, and we work this out as being -1, 1, -1 by taking the coordinates of P away from Q. In a similar manner, we will use PT as our C, giving us -2, -1, 3, by subtracting the coordinates of P from T. We can then just say that R equals 1, 2, 0 plus lambda -1, 1, -1 plus mu -2, -1, 3. Of course, we could have jumped on using Q and then found different direction vectors lying in the plane by looking at QT and QP. Or again, we could have jumped on at T and found different direction vectors lying in the plane. So there are many different ways of writing an equation of a plane in parametric form. In the next video, we will see how to form the equation of a plane using the normal to the plane.